Hi everybody, this video is dedicated to all y'all Disney fans, all y'all Tangled fans, because we are talking about Pascal's triangle. Okay, so let's first talk about expanding these binomials here. So if I have a plus b squared, remember guys, we are never ever going to take this 2 and distribute it. Don't distribute it. That is just saying write a plus b in parentheses twice and then multiply it together. So we can do that. Same thing here. Do not distribute that 3. It is not a cubed plus b cubed. Write it 3 times, multiply it together, and then we are going to combine all of our like terms so we get that fabulous answer. Then we can do it one more time and we get all that mess. And I'm like, ugh. I do not want to have to do that every time. Well, good thing, because we are going to talk about Pascal's triangle. So this was a lot of work to do this, and I'm going to show you how to utilize this binomial expansion here and relate it to Pascal's triangle. So for those of you who like super cool videos, Pascal's triangle is so awesome. There are applications that we're not going to talk about in this class, but if you guys want to see kind of how it derived, what other people use it for, click on that video. I think it's pretty short, really cool. But anyway, so let's go ahead and talk about this. What I want you to do is really quickly pause the video, see if you can find any patterns between the binomial expansion, the original question, maybe this Pascal's triangle over here. See if you can find any pattern. There are more than one. Okay. So we're going to talk about this binomial expansion, and we're always going to have it in the form a plus b raised to the n. So that is always going to be our original question that we are going to try and multiply out. And these 5 terms are going to be true every single time. So I kind of put it all together on one so we can kind of see what's happening here. Okay, so the first thing is that there are going to be n plus 1 terms. So here's our n value right here. So I'm going to look here. So I have 0, so I'm going to have 0 plus 1, 1 term. Cool. Here I have 1 term, so I'm going to have 1 plus 1 is 2 terms. 2 means I'm going to have 3 terms, so on and so forth. So that's going to be how many terms you have. Next, the coefficients are going to resemble the Pascal's triangle in the coefficients. So notice how it says the nth row. Y'all be so careful when you are doing this. Notice that here we start in the n equals 0 row. So really, when we're counting, don't count from 1 here. Count from 0, 1, 2, 3, so on and so forth. So this is like row 0. So in row 0, your coefficients are going to be 1. Okay, so let's go down to 1 like down here. So notice I have a plus b raised to the 3rd power. I'm going to the 3rd row starting with 0, 1, 2, 3, and Pascal's triangle is going to be 1, 3, 3, 1. And maybe you're like, Miss Kish, Pascal's triangle is cool. How do I get Pascal's triangle? Pascal's triangle is going to start at 1. And then you are going to put a 1 and a 1. And then after that, all you're doing is you are adding kind of like your, like a triangle. So 1 plus 1 will give you 2. And then you're going to always have the outsides be 1. Then start again with 2. 2 plus 1 gives you 3. 2 plus 1 gives you 3. Always have 1s on the outside. Put another 1. Then you're going to keep on adding. 4 plus 1 gives you 5. Now we have another inner term. 4 plus 6 gives you 10. 6 plus 4 gives you 10. 4 plus 1 gives you 5. And that is how you can build out that Pascal's triangle, because you will not be given it on a test, which is okay, because now we know how to build it. Start with 1, then 1, 1. 1s are going to be always on the outside, and then you are just adding in kind of like those triangles, adding the 2 numbers above, and that'll give you your Pascal's triangle. And again, that is super important because we're going to use that to build our binomial expansion, and that's going to be the coefficients of each term. So again, this bottom one down here, coefficient is 1, 5, 10, 10, 5, 1. Pascal's triangle is 1, 5, 10, 10, 5, 1. And again, write it down. You are starting at row 0. So this row right here is row 0. So 0, then go from there. Okay, so next we're going to talk about the exponents. So I'm going to kind of talk about these together. So it says that the exponent of a is n in the first term and decreases, and b is 0 in the first term and increases. So let's look at this guy. I have a plus b raised to the 3rd power. So my first term, a is going to always be the 3rd power. Then I'm going to decrease. Notice then it's a squared, then just a, then it's a to the 0, which is just 1, so you don't have to write it. So that's your a's. Your a's are going to be decreasing in power, and b, you're going to be increasing in power. So start with b to the 0, which is not there, then b to the first power, b squared, and b cubed. So again, your a's are going down and your b's are increasing. And because of that, this last one, it says the sum of the exponents in any term is going to be n. So notice this is a plus b to the 5th power. Every single term needs to be degree 5. So remember, these are all monomials, and we know that we can find the degree of a monomial by adding up all of the exponent powers. So again, this is degree 5, a to the 4th plus b to the 1st, that is 4 plus 1 is 5, 3 and 2 is 5, 2 and 3 is 5, so on and so forth. So you will need to utilize these 5 facts because we are going to use this instead of multiplying out a plus b 5 different times. We're going to use this pattern to tell us what our answers should be. So stay tuned in the next video and I'll show you guys how to use Pascal's triangle.